Good morning. Another day of algebra. We're getting really close to our test on linear equations on Friday. This is the last lesson. We skipped this one a while back on lesson 30 because we had a day off there, and I wanted to keep that momentum going on slopes and things like that. And so this is kind of similar to slope direct variation, but so anyway, we're going to come back and get this one before the test. All right. So here's your warm-up problems. If you'll do those real quick, I have the answers on the next page, and let's see how you do. Number 5 is from 8th grade, and it probably would have been taught around 4th quarter, so you might not know how to do number 5, but we'll talk about it. We'll catch you up on how to do that. All right, so come back when you're ready. All right, so here's my answers. Remember, coefficient is going to be very important from here carrying on. Coefficient is a 3. Coefficient means the number in front of the letter. Number 2, I have it over there on the far right there. Y equals mx plus b form. Solve for y. I got negative 3/2 x plus 4. And number 3, I did y equals 3/5 x. Back to range of functions. If they give me the domain, all I do is plug those in. Solve the problem. So my first one is a 0, 3, because 5 times 3 is 15. 15 divided by 5 is 3. And then 10 times 3 is 30 divided by 5. So they're mental math problems. Make sure you have a bracket. Now let's talk about this percent. The word of and percent of, this is a times sign. So what percent of 160, so I'm looking for a number, times 160, the word is always an equal sign, is 88. So really I had 160 ends here. So what I did is I divided by 160 on both sides, and I got a decimal called 0.55. Well, they wanted in percent form, and if you remember back to 7th and 8th grade percents, we moved the decimal to the right in 2 places and put the percent sign. If we want to get rid of the percent sign, we move the decimal 2 places to the left to get back to a decimal that we can work with. A very important percent rule that we need to remember. All right, and the last one, get it into slope-intercept form. Should it be getting that really nailed out there? Y equals 1/4 x minus a half. You could have had 0.5 or a half, either one. All right, so today we're doing direct variation. And the thing about a direct variation is our slopes are all the same. And so this happens all the time in real-life problems. So like here, you're making a rice, and for every cup of rice, it makes 5 servings. So if I have 2 cups, it goes up to 10, 3 cups, 15. And so if I was to write the equation for this, it would look something like this. Y equals 5x. Notice that I don't have a b here. If I was to put it in the y equals mx plus b form, I don't have a b. So that's kind of a clue, a very good clue that this is a direct variation. I only have a slope, okay? And so let's talk about it some more. Looks like my computer froze up here. So this is where things get kind of a little bit crazy for algebra because they just keep messing with different things. So a direct variation is a special type of linear relationship that can be written in this form. Y equals kx, where k is a non-zero constant called a constant variation. Constant variation is just another word for slope. I don't know why we just don't say, hey, if it's y equals mx, then there's no b. So if we can write it in this form, and again, the clue is there's no b, then it's a direct variation. Okay, so for example, on our first one there, it's already in the y equals mx plus b. So this is a direct variation. It's a direct variation, and when we go to say what our k is, if so, identify the constant variation, we would just say k now instead of an m, because we're talking about constant variation, and then basically it's the slope. K is 4. If I got this one into the y equals mx plus b, I would add 3 x's to both sides. I get 5y equals 3x. Last step, get that 5 out of there. I was helping some people online the other day, and I can tell they weren't doing the lessons earlier because they don't know how to get the y by itself, like divide by a 5 on that problem. And so now they're kind of seriously behind and trying to catch up. I appreciate that they want to catch up, but man, you missed a whole bunch. 9 weeks worth of work on how we can do this quickly. All right, back to this. So notice again, in the y equals mx plus b, I don't have anything additional after this x here. So again, this is a direct variation. And so, if so, identify the constant variation. So again, we're going to use k on direct variations instead of an m. K equals 3/5. It's the slope. Notice this one here, I would do a minus 2x. I get y equals minus 2x plus 10. And notice that I do have something after. I gotta get rid of that 10 there quick. Plus 10. I do have something after this. And so if they ask me, well, why not? You would say can't be put into the y equals kx form because we have this plus 10 here. So this is not a direct variation. I'm not sure why my pad's not working today. The computer's really slow or something. Okay, so that's not a direct variation. So I can't identify the constant variation because it has that plus 10. All right, give it a shot. The trick is to put it into y equals mx plus b form. And then if you have a b, it's not a direct variation. Can't be put into that y equals kx. Okay, let's see how you did. So here's my answers. I even wrote here, why not? It can't be written in the y equals kx form. So the first one was not, and the other two were direct variations. It was a negative 3/4 and a negative 3. All right. There it is. What happens if we solve for the k? Now, this is kind of important because this is just their way of saying, hey, I want to divide each side by x, so I get y over x. Isn't that the same thing as slope? It is. Same thing as slope. Rise over run. So sometimes we just use that y over x to help us identify some things. So here we're going to identify as whether it's a direct variation by just looking at two methods here. We could write an equation for this in the y equals mx plus b form. What is happening to my x to get my y? If I put a 1 in, how do I get it up to a 6? Well, I could add 6. Add 5, sorry. 1 plus 5 is 6. But if I put a 3 in, 3 plus 5 is not 18. So it's not adding something. So let's go back. What if I times it? What if I said put a 1 in for x? I would have to times it by 6, right? So then if I put in a 3 times 6 is 18, 5 times 3 is 30. So yeah, there's my equation. So if it's in the equation form, we already talked about that up above, that's in the y equals kx form. So this is a direct variation. And they explain can be put into y equals kx form. That's how you would explain it. All right, now there's another way to do this is we can take these guys up here and just keep putting it as a ratio of our y over x. 6 over 1, that's reduced down to 6. If I do 18 over 3, that reduces down to 6. And if I do 30 over 5, that reduces down to 6. All right, so it is a direct variation. And how you would explain that if you use this method is you would say all the y over x's are the same. I like this one when they give me a chart to show that as a direct variation. Writing the y over the x's. All right, let's go over here and let's write this equation because this one's a little bit interesting. again, what we decided so far is if I put an x in, I try this first, I put a 2 in, what do I have to do to get down to a negative 2? Well, I have to subtract 4, right? So now if I put a 4 in, 4 minus 4, yep, that equals 0. Look at that, I think we hit it off right off. I put an 8 in, 8 minus 4 is 4. So there's our equation in the y equals mx plus b form. Now, is it a direct variation? No, because I have this guy right here. There's a 1 in front of this, so that's 1x, but it's not a direct variation. Can't be put into y equals kx form. Sometimes kids will say it has a b, but this is a better way to explain it. Now let's use method 2 if you didn't want to write the equation, because sometimes writing the equation right now for you is hard. It's just guessing and checking and trying multiple strategies. So again, this is why I like method 2. If I put negative 2 over 2, that equals negative 1. If I put 0 over 4, that equals 0. And so right there, I can say, well, my y over x's don't, so this is not a direct variation. So again, you can see how that side's much faster. And I would say here, the y's and the x's are not the same. All right, so that's that. Here's 3 for you to try. Again, if you like writing equations, go with that, but you might just try the ratios of y over x, and see. All right, when you're done, come on back, and I have the answers on the next page to see how you did. Okay, so first one I got not a direct variation. The y over x's are not the same. The next one, when I did all my ratios and got it down to a unit rate of 1, I got negative 4. So they were all the same. And the last one, not a direct variation, I stopped. We had a 2.5, a 3, and then a 4. Okay. All right. So here we go on writing direct variation equations. Now, there's 2 ways to think about this. We can write the equation, which is kind of a little bit more challenging, but let's have both strategies here. So if we went with that formula called y equals kx, the first thing we would do is they said, okay, find the, if y is 6 and x is 12, well then find what happens when x is 27. So what we're going to do is we're going to put that 12 and the 6 for the y here. We're going to put the k there and put the 12 here, and let's solve for the k. We're finding our slope basically. So I want to divide by 12. So my k equals 0.5. Now that I solved for my k, I want to now find what happens if it's a 27. So we go back up to our formula. Y equals, here's my k, it was a 0.5. We solved it over there, times 27. And so now if you take 0.5 times 27, you get 13.5. Now that's one strategy. Sometimes kids forget that one. And so what I like to use is this thing called a proportion. So if we take the given up here of y over x, and again, it's always y over x, rise over run. I put my 6 on the top, put my 12 on the bottom, and I put equals to, and then see how this one says x is 27. Well, x's need to be across from x's. So I'm going to put 27 down here, and I want to find this number up here. So I'm going to cross multiply. That would be a 12n equals, and 6 times 27 looks like it's 162. And now if I divide by 12, I get n equals 13.5 as well. And so I like using the proportion method. It seems to be a little bit faster for me, but it's good to know both. All right, so now you give it a try, whichever method you want. I have both answers on the next page here. When you're ready, come on back. So let's see how you did. I did the ratio method. I put an accent there, but I got 90. And there it is if I wrote the equation over there. I solved for my k, which was 9. And I rewrote the equation and plugged the 10 in for the x, and 10 times 9 is 90. So again, whichever method you like. All right, so now graphing this. Will you do me a favor, though? As I was looking at my graph here, I brought over trying to save you some time on graphing, and I put in a graph that was not a very good coordinates there. So would you quickly change your graph to those scales? All right, so this is a sloth that's extremely slow on the ground. It travels at a speed of 6 feet per minute. Write a direct variation equation for the distance a sloth will travel in x minutes. Well, sometimes if we go over here and we say, okay, in 1 minute, when did he travel 6 feet? In 2 minutes, when did he travel 12 feet? And so what are we doing to our x, which is this 2? We're multiplying it by 6. So if we wrote a direct variation equation, we would say y equals 6x. He goes 6 feet every minute. Now we have to put things down here, labels. This is time, because that's my x there. If he goes for 1 minute, he goes 6 feet. And this is in minutes. And then over here, we're going to have distance in feet. All right. Yeah, let's go ahead and do one more. 3 would be 18. And actually, we already chose the pair, so we just kind of worked it backwards. We took the graph and we did our coordinates. So now we're going to, because it's time, it's going to be a continuous graph. Again, that will never go away. We should always think about whether we're going to have a continuous graph or a discrete graph. We're going to draw our line, put an arrow on both ends, because we can have a decimal of time. We connect the points. Okay. Now, something also that's very important. If I looked at a graph and I said there's a direct variation, remember on y equals mx plus b, this is kind of an added bonus here. And on direct variations, remember we said there's no b. So if I see an equation like y equals 3, 6x, notice that the b is a 0. So another clue about a direct variation, if I'm just looking at a graph, if it goes through 0, then it's a direct variation. Okay, just an extra tidbit there as you're looking at graphs. Sometimes they'll say, hey, look at this graph and see if it's a direct variation. Okay. All right, so here we are on the try it. Now I want to do this one with you, because a lot of kids kind of mess up on this one thinking about perimeter of a square, and it varies directionally with the sides of the length. So I always begin by drawing pictures, because it is really kind of a confusing problem. So they said it varies with the sides. And so if I had a square here and each side was 1, well, what's the perimeter? Perimeter means the distance around it. So if I had a 1, I have a perimeter of 4. If I had a square now that was a 2, 2, 2, 2, so I put in a 2 and I get 2, 4, 6, 8. And if I had one more, I'm going to just do one more. I have a 3, 3, 3, 3. So 3, 6, 9, 12. Ain't I taking a number and multiplying it by 4? So if I had a 1, 1 times 4 is 4. If I have 2's, 2 times 4, because there's 4 sides is what the deal is. So now I can write my equation. Y equals, I'm taking 4 times x, whatever the x is. Okay, so then we can come over here and graph it very easy. 1 is 4, 2 is 8, 3 is 12, 4 is 16. Now, I'm going to leave it as a discrete graph because you can't have a decimal. Oh, we need labels here. So this is the length of the side. Yeah, like to the side. And then over here is our perimeter. Again, I don't know, man, that was, hopefully we're coming to the end of the video. Yeah, it's just giving me all kinds of fits. All right, so the perimeter. So that's kind of how that goes. And again, think about whether it's a discrete graph or a continuous graph. That's not going to go away. Okay? All right. Last thing is on your practice sheet. Sometimes things get a little crazy here. So if you look at this one here, remember what Fisher said about, there's no b here. So solve for y if needed. Well, it's already in the y equals mx plus b form. So they said yes. Is the equation in that form? You right? Yes. Is it a direct variation? Yeah. What's our constant variation? Well, it's the coefficient of our x. That's why we had that on our review. This one here in the y equals mx plus b? Sure is. So we don't need to solve it because it already is. Is it a direct variation? See how we have a 10 there? So we can't put it in. So we say no. Is it a direct variation? No. Well, we can't have a constant variation if it's not a direct variation. Okay, so we just leave that one blank. Now this one you're going to need to do some work to get it into that y equals mx plus b form. That's really not what I wanted to talk about, although we did. All right, so there it is using our ratio of y over x and getting it down to 1. But this one, well, I think it's on the next page. Yeah, it gets a little confusing for kids because this is when we're starting to shove things into that y equals kx form and trying that second method. So what they did is they said the x and the y. So here's my y is a -2. So notice they put that where the y is. They said my x is a -4. So they put that where the x is. Now to solve that, wouldn't we divide both sides by a -4? Okay, so -2 divided by -4 would be a half, right? So now if you remember back to our notes, we're going to put a half right here for the k, because there it is. So I want to put it as a decimal, 0.5. And now they said, well, put an 8 in here. Well, 0.5 times 8 is 4. Okay, so this one over here is kind of the same thing. They're using the equation to solve the problem. All right, so there's a couple more when they're not helping us as much. Okay. All right, that's it. Tomorrow we'll have a review. So we'll do that review and then I'll post the answers on the internet and you can see how you did in preparing for the test. I'll also make a video of the whole review that when you're done grading it, if you missed any problems, you can just go right to the video to see how and why you missed it. On test day, it's very important that you have that test done by 4 o'clock. So budget your time somehow because I'm going to close the test window at 4 o'clock. All right. So make sure you get the test done. You're going to have to take photos of 4 pages and you're going to have to submit them like you did before. Each page needs to be submitted individually. All right. Some of you are using that program. I can't remember. Let me get back out here to what it is. This one up here. Kami. If you're using Kami, Kami's okay, but you're finding out that some of the problems with Kami is that sometimes it's hard to write fractions and things like that. And so kind of be careful with that Kami. It is a good tool, okay? But if you can't get the answer that you want or the graph to go the way you want because Kami has restrictions, then you might kind of just print it off and do it in handwriting and take pictures of it. All right, so with that, I think we're all done for the day, and I hope to see you tomorrow. Let's see if I can get out of here. There we go.